Hello, ladies and gentlemen. Today I will present a topic titled Dietary ellagic acid supplementation attenuates intestinal damage and oxidative stress by regulating gut microbiota in wearing periods. Early wearing or periods around 3 weeks of the year leads to tonsils and various severe intestinal damage, infection, and diarrhea. Ellagic acid, a polyphenolic compound with strong antioxidant capacity, reported to modulate gut microbiota and support intestinal health.
Objective: to investigate the effects of dietary supplementation with ellagic acid on reducing intestinal injury, oxidative stress, and gut microbiota imbalance in weaned piglets. Hypothesis: dietary supplementation with ellagic acid can improve goal performance, reduce intestinal damage, and elevate oxidative stress in weaned piglets by modulating gut microbiota balance. The role of gut microbiota in mediating the effect of EA can be evaluated through fecal microbiota transplantation. Experimental animals and grouping. A total of 126 weaned piglets, aged 23 plus or minus 1 days, were randomly divided into 3 groups for 14 days. Control group received a basal diet and 2 milliliters of saline orally. EA group received a basal diet supplemented with 0.1% ellagic acid plus 2 milliliters of saline orally. FEA group received a basal diet and 2 milliliters of fecal microbiota suspension collected with from EA-treated pigs orally. Data correction and analysis. First, growth performance. We record the average dairy gain, average dairy feed intake, and fecal score. Second, intestinal morphology and barrier function. We examined the virus height to creep deep radio epithelial cell apoptosis using the journal assay, and the expression of tight junction proteins including occurring and codin 1. Third, oxidative stress and antioxidant capacity. We determined total antioxidant capacity, catalase, glutathione, malondialdehyde, and analyzed the expression of antioxidant-related genes such as OH1, GCLC, and GCLM in the jejunum. Lastly, gut microbiota analysis. We performed 16 srDNA sequencing to assess alpha and beta diversity and microbial composition. We also conducted functional prediction using PLAS T2 and measured short-chain fatty acid in the colon and jejunum. 3.1 Effects of EA and FMT on growth performance and intestinal health. In this study, supplement with ellagic acid and fecal microbiota transplantation significantly reduced diarrhea incidence and improved the average dairy gain of weaned piglets. Both EA and FMT enhanced the intestinal barrier integrity by upregulating tight junction protein like chlorine 1 and occludin, which reduce the intestinal permeability.
In addition, EA and FMT increase antioxidant indicators GSH over GSHG, TAOC, and CAT, while reduce the oxidative marker MDA in intestinal issue. Overall, these findings suggest that EA and FMT improve intestinal health, alleviate oxidative stress, and enhance growth performance in green piglets. 3.2 Effects of EA and FMT on intestinal morphology. EA and FMT supplements significantly increase villus-high and devillus-high to Krebs ratio, indicating improved nutrient absorption capacity. Furthermore, both treatments reduce epithelial cell apoptosis, as confirmed by the tunnel assay. In summary, EA and FMT strengthen the intestinal epithelium, reduce cellular degeneration, and promote better digestion and absorption efficiency. 3.3 Effects on antioxidant and inflammatory genes expression. EA and FMT treatment upregulated antioxidant-related genes, including HO1, GCLC, and GCLM, thereby activating the intestinal antioxidant defense system. At the same time, the expression of pro-inflammatory cytokines such as IL-6, IL-1 alpha, and IL-1 beta was reduced while the anti-inflammatory cytokine IL-10 was significantly increased. This result demonstrates that EA and FMT enhance antioxidant defenses and strengthen intestinal inflammation in green piglets.
3.4 Effects on gut microbial diversity. EA and FMT supplementation lead to a significant increase in microbial richness and alpha diversity, indicating a more balanced intestinal ecosystem. Principal coordinate analysis of PCOA liberate distinct microbial community structure in the EA and FEA groups compared with the control, confirming that both treatments modulate gut microbial composition. Therefore, EA and FMT improve microbial balance and diversity, which are key indicators of intestinal stability and health. 3.5 Effects on gut microbial composition. EA treatment increase the relative abundance of beneficent bacteria such as Teneliculic ruminococcus and Akkermansia muscipula, while researching potentially pathogenic bacteria, including Parabacteroides and Clostridium rhomosum. This microbial shift supports and healthier intestinal environment and strengthen the host immune system. In summary, EA and FMT promoted a benefit microbial composition, contributing to improved gut and immune health. 3.6 Effect on microbial metabolites. Short-chain fatty acid SCFAS, EA and FMT significantly increase the concentration of short-chain fatty acids, including acetic acid, propionic acid, and butyric acid, in both jejunum and colon. Their SCFAS serves as an important energy source for intestinal epithelial cells and play a role in reducing inflammation and maintaining mucosal integrity. Thus, EA and FMT enhanced microbial fermentation activity, resulting in improved gut metabolic function, and intestinal health. 3.7 Correlation analysis between gut microbiota, antioxidant inflammatory indices, and SCFA productions. The Spearman correlation analysis revealed clear association between beneficial microbiome and host physiological indices. Parabacteroides showed negative correlation with SCFA levels and positive correlation with intestinal core apoptosis. Fibrobacterias, Ternericutus, Ruminococcus, and Eosinophila were positive correlated with antioxidant gene expression, antioxidant enzyme activity, and SCFA concentration were negatively correlated with oxidative stress markers and inflammation-related cytokines. Viplavula and ceramosum were also associated with higher antioxidant activity and lower inflammation.
In summary, the present study demonstrated with dietary supplementation with 0.1% ellagic acid significantly improved diarrhea, growth performance, intestinal damage, gut microbial dysbiosis, and intestinal antioxidant capacity. Focal microbiota transplantations further suggesting that the gut microbiota mediated these benefits co-effects of dietary supplementations of facilitating varying transitions in piglets. Thank you for your attention.